Okay, today we're going to be talking about procedural foliage tools. Now, these tools were all written by us, and they're all custom, and they have to do with populating the terrain or the landscape with specific actors, including foliage and things like that. So let's start off by showing the custom spawner. So what this guy does, let's just go to the base class. So this is the C++ class that is responsible for providing a box component or a box extent where you can specify where to spawn, and then you also have a list of classes that you specify. Now these are actors, not static meshes, so you can specify blueprints and things like that. So that's what this particular spawner is for, and then you can provide some things like the minimum, maximum scale, the pitch on roll maximum. That's in degrees, so it's in XYZ. So that's pretty useful. And then you can also optionally specify landscape layers, and the blend isn't actually used. You can specify how many actors you want to spawn, considering this is all random, and then you can specify a random seed. Now this random seed ensures that every time this process is run in editor, that it always yields the same results. And then none of the spawning code here will actually be packaged. So this is all wrapped in with editor. So let's start by taking a look and see how we can practically use that. So I just created a blueprint here from that C++ class. So that I can set the spawn class here. So the spawn class for this guy is this terrace rock. But then what I've done was I created another child blueprint from that guy, and I've actually overridden the spawn class with this guy, which is almost like a terraced rock kind of guy. So it's actually got comprised of multiple meshes that all have level of detail, and they all have their culling distances set, so their draw distances set. So then what this spawner then is going to go and do, it's going to go and use these properties to go and populate this landscape. That's the first thing I wanted to do. So I just simply drag and drop this blueprint in here. So this is called custom spawn grass blueprint, right? So you would drag this in your level, put it somewhere, scale up your box extent. You can see here the box extent here is highlighted in yellow. And then if I were to run this just by hitting this run simulation, and I'm telling this spawner I want about 32 of these spawns, so let's hit it. And now you can see they're here, and these are fully interactable. And you'll also see they're not all facing the same direction. They should all have a random yaw applied as well. Okay, so that's the idea. It would place these all across the map. And like I said, you can move them around. If you don't like something, you can change it. Right, so now I've got these guys on my terrain, but let's say I want something more here. And you can see there, if you were to save and reload this, they'll still be here, because all that code did was just dropped it in here as actors in the editor, and then set some properties on them, which is what I wanted, because this allows me to still come in here and make individual changes, which is important. Now for the next one. This is called the vine draper. Okay, so then what I wanted is I wanted to drape these vines, like these here, these vine splines or whatever. I can just get some control of my mouse speed. These vines, I wanted to drape these across these meshes here procedurally. So the first thing I want to do before I do that, now just keep in mind these are all custom tools that we wrote. So you're not going to find these on the App Store or the marketplace or things like that. We don't intend to sell these tools at the minute. We're just we're going to be using these. Right, so I'm just adding a tag here called vine drape over those terrace rocks. And then I'm going to go to this vine draper tool here. Now this tool comes from a C++ class once again, and you're going to see they all follow a very similar pattern. They all run in editor, and they all have a few common settings like scale and density and things like that. The random seed, the run simulation and remove all allows me to, when you make a change to this in the editor, to fire some code, and this code will only run in the editor. So you also specify the spawn class that you want. But this guy works quite a bit differently. Quite a bit different. He's got a box component here as well. So that's going to tell him where to spawn, and you also need to tell him what to spawn. So that's why these there are 3 blueprint classes here that have been specified. So I'm just looking on the side here. So the first one is this guy will spawn this, and the type of classes are very specific. It has to be a type of spline actor. Now, all the spline actor is it's really just a class that exposes a static mesh to use as a spline mesh, and then a spline component, and then it has some code that runs in the construction script. I'll probably make a separate video on that. That will just go and set the mesh on the spline, and that's what you see here. So these guys are all these spline actors. So back to the spline spawner, or this vine draper. So this guy has 3 blueprints here specified. One of them specifies this vine 2 class. They have their forward axis set, and this extend offset is also pretty cool. That allows you to push, because there's usually a gap between the meshes as you place them on the spline. So you can use that extend offset to push the next mesh in the spline point just a little bit backward, so it looks like it's nicely joined. I can show exactly what I'm talking about here. For example, if I were to change the spline offset or the extend offset for this guy, you should see it change. So you can see there, it's actually adjusting the splines, adjusting the meshes on the spline. So if I were to set this to 0, you would actually clearly see gaps between and like right there, you would see a gap. So all that does is it just tries to negate that. So it looks like more like it's one continuous mesh. Alright, but more on that in a different video. This is more about the actual tools and how to use them. So you would place this the vine draper blueprint, which have these 3 blueprints spline blueprints set here. You could also use C++ classes here. It's very specific. So you could subclass it in C++ or blueprint. I prefer blueprint because it's just, for me, it's faster iteration to make changes to them. And then I've set here on the min and max scale between 1.5 and 3, but it actually needs to be much higher. It needs to be almost like between 5 and 10 or something like that for the vines to look interesting, because this is just too small and too thin. Alright, so the random seed is set, the density I'm setting it to 0.8. Your vine draper here, and then when you run the simulation, now remember I've set these the tags on these guys. So I'm telling the spawner I want to drape vines across these meshes. So all of these guys will have those tags set. Okay, so the density says out of let's set this to 0.1 for example, and see if we can find which one did it drape. So this guy here, yeah, okay, let me remove this. Put the debug mode on. So I've set it to 0.1, and when I run it now, it should have chosen, it chose 3. All right, it's incredibly slow because of all the debugging that it's drawing. So it chose these 3 to spawn these vines on. Now you can see all it was doing there was just giving you some debug. I can run it again. It's just giving you some debug information, showing you the extents, showing you where it decided to drape the vines along and things like that. So it's going to be incredibly slow because it's drawing this here. These debug draws are very expensive. So let's get rid of those. Let's run a remove all, and I'm going to set this density up to something like 0.8. So that means it's going to be draping vines across quite a lot of these meshes. And how the draping, or if you want to call it, algorithm works is it looks for the middle of the actor first, identifies which component it hit from the top, and then it just chooses a random direction, whatever. So it around the z-axis. So yawing, it does a random yaw and then chooses a direction and then starts moving out and trying to find the edge. Meaning it hit another actor and while it's spawning raised down from the top, or it hit a different component to what it hit initially. Now it knows how far it can drape the vine. So it then gathers those points, decides which of those points to use, and then simply drapes the vine according to those points, and then does that a few times. And that entire process is also repeated a few times. So that's why you get the effect like there's more, quite a few of them on there. So I'm just going to run this sim on 0.8 and you can see it runs pretty fast. I've run this on 128 of these as well in our one of our bigger levels, and it ran fine. And you can also see, let's give this a play. You can also see the, okay. It also has a level of detail, and it also gets cold. So if you look into the distance there, you're not going to see anything. Let's see if we, as we move closer. Unfortunately, Unreal Engine has a bug at the minute with 421 where, there we go, it just popped in, where the spline meshes actually ignore the max draw distance. So we had to write our own custom draw distance using squared lengths. With a almost like a manager actor or manager blueprint where all of these guys register themselves. Actually not register themselves, these guys all have tags as well. Custom cull, so anything that has custom cull on its tag will be handled by that custom color. It's probably only going to be used for the spline mesh, and we have used it and tested it in our big level as well, and it only runs like once every 5 seconds, checking for when to cull these. And then these guys also have, obviously they have a level of detail, so as you move further away you'll see it doesn't always stay at the highest level of detail, so that also helps with performance. So that's the vine draper. So you can see what it does. It basically drapes vines across any meshes that you specify. Now we could change it to include more parameters, for example, to drape more or to drape less, but really the thing we're just looking for is just a little bit. This has got nothing to do with the game, really. This is just for aesthetics. So this is what we wanted. We just want some vines draping and drooping from this, and you can see there's a little bit of randomness in these splines. I've set their draw debug to false, so you can only see the splines when you select them. And also these splines are actually interactive, so I can actually move these splines in the game if I'm not happy with something, if I really wanted to, after it's been placed, and it'll remember that. So when you save this and you reload it, it'll remember it. It should also obviously go through to the packaged game, so that should also work fine. So that's the vine draper. And some of them it didn't choose, so we specified the density at 0.8, so this one didn't pass the test. So about 20% of them won't have vines draped across them. So that's the vine draper. And then there's one more tool. One more important tool for our procedural foliage, from our procedural foliage set, and that is the we actually just call this custom procedural foliage. Now this works very similar, except it's not as optimized, or it doesn't use the same algorithms as the procedural foliage spawner, but it works in the same way that it uses let's just go to the base class quickly here. It uses an instanced mesh. It spawns an instanced mesh. Now this is also one of our components that we created ourselves, which just contains an instant static mesh component, because we don't want to be spawning these components runtime. We want these in editor time. And what we found is if you spawn components in at editor time here, and then try to add them in here, actually very weird things happen. It's almost like it wants those components to be either spawned in runtime or created via the main blueprint or whatever. So for example, if I come in here and I add a component here just to this blueprint here, and when I do it through code, there are differences. So and it's not that easy to figure out what the issues are. So it was just much easier for us, and it's much easier to control by just creating these actors for ourselves, like the static mesh actor, and then using this guy and spawning this guy in the editor. So that's what our procedural foliage actor will do. So we can actually tell this guy which static meshes to spawn, and it will use obviously the instant static mesh component, actor and component that we specified there. We specify spawn density, min and max scale, and it will automatically align to surface. So the algorithm's obviously very much simplified, and this is not for terrain. This is actually going to be for actors, but it could be for terrain, because it's actually all based off of tags. So depending on the tag that you specify in the meshes, it will actually spawn this foliage on top of it. So we're choosing to spawn grass. Let's take a look at the grass quickly. It's the same grass we're looking at for the main game. So this was created in SpeedTree. Not the best looking grass. And then there's this bush, a couple of bushes and a couple of boulders out of quite a lot that we have. We do have a lot of bushes and boulders, and obviously not going to put all of them in here. So there's a little bushy little thing. It's not really a bush, it's more just like a little plant. So that is what we've specified for it to spawn. And then what we need to go and do is we need to go into these guys again, and there's an easier way to do this. I can just go and just select them all, and for this guy the tag that I want is, I think it's called grass drape, I think so. This guy does not have an extent. So and how this works is you add each static mesh that you add here will have an accompanying and matching by index density. So I'm telling it for the grass, I want to spawn the grass on these meshes at a density of 0.8, so 20% of the mesh shouldn't be covered. And for this guy here, and the algorithm actually uses a grid So it breaks the mesh up using its extents and breaks it up into a grid, and then moves across the mesh in a grid fashion, deciding when to spawn based on the density. So there's going to be a lot of grass, a little of these bushes, and then a lot less of these boulders and rocks. So if I hit simulation, I could also run it in debug mode for one of them, but it's not really going to show a lot. It just shows more in the log. So I'm going to run the simulation here. Takes a few seconds. This is on 32. Here we go. It's done. And that's what it did. And you can see some of the grass are floating because the grass isn't always, it's obviously also spawning here on the edge of this mesh here, so it doesn't know that it's on the edge. Yeah, so it's not perfect yet. There's still some issues to sort out regarding the alignment, but it does work. It has the culling set. It spawned a couple of the bushes too, and you can see the frame rate isn't terrible. It's still staying at 120. So let's move to this guy here, and you can see there it started draping the grass here. The grass itself isn't super optimized. You can see there's a lot of overdraw there. We'll probably try and fix that in an overdraw pass. But this just gives you an idea of the procedural foliage tools that we are using and developing. And we've also applied this and run this in our semi-open world level, where there's about 130 odd of these slate rocks here, and it works for them. It actually ran and didn't crash, give any errors. All right. So that's just showing some of our tools that we're going to be using. I think that's going to be it for this video. Thanks for watching.